Hello, I'm Dave Furgeson. This is EST 581, presentation number 7. I'm very, very happy today to have a very special guest, Dr. Ed Kaplan from Brookhaven National Laboratory. Dr. Kaplan is a senior scientist and group leader at Brookhaven National Lab in the internal dose assessment group, and he has a whole bunch of honors and awards to his credit, certainly a national leader in environmental systems engineering. Dr. Kaplan has 25 years of experience in environmental systems and radiation effects engineering and has worked on many problems related to groundwater issues in Suffolk County, Long Island. I'm very pleased at this time to introduce a nationally recognized scientist, Dr. Ed Kaplan.
Thank you very much. Do I? I don't have to use this. I'm very honored to be here tonight. That was a great introduction. I see a lot of my students here from 595. Hope that for those of you who are not taking 595, that some of the things I tell you interest you enough so that maybe next year I can see you, or in the springtime taking 596, which is numerical modeling for environmental problems. What I'd like to do tonight is give you some insight into a problem that affects us all very intimately, which has to do with our drinking water here in Suffolk County. Let me just tell you how I will lay this lecture out. First, we're going to talk about theory. And then we're going to see about what really happened. Some of the insight I can give you will have been gleaned from my own membership on some technical committees where I had an opportunity to work with colleagues and with politicians. Those of you who I teach in 595 know that there are frictions that occur. And hopefully I'll give you some insight into those from the perspective of a scientist, but also an engineer. Even though my title is scientist, at Brookhaven I'm an engineer. At least I think of myself as an engineer. And I'm very practical. After all, we engineers are interested in theory, but we're interested in doing things and making things happen. And so hopefully you'll get some of that perspective from what I have to say. Let me give you an idea of the setting that we're talking about here. I can't speak for you, but I can certainly say that I'm here because I like living here. Sure, the taxes are very high, very, very high. But Suffolk County is a particularly nice place to live. We're still New York State's largest farming county, believe it or not. We have a lot of open space, and we have water to the north and to the south, boating, fishing, swimming, that sort of thing. Now, from the point of view of drinking water, we are in an area which is known as a sole source aquifer region. And this is a legal definition. It comes from a bunch of federal laws, the Clean Water Act, Safe Drinking Water Act, that sort of thing. And it means just what its name implies. People who live in a sole source aquifer region depend 100% on groundwater for their drinking water. And we're in that position. If you're in a place where there are no activities to affect the groundwater, you're in luck. Such places are very difficult to come by in the United States at this point at the end of the 20th century. So our drinking water supplies are increasingly jeopardized by things that people do. And this sprawl of growth of people and the things that we bring with us has been marching eastward. So If you had been here 20 years ago, when I came here, you would not see as many homes. It was already developed, but at that time, our neighbors were complaining about the university. What a terrible thing to put up this university over here. It was so beautiful. Well, here we are 20 years later, and we can see the future heading east. So we have to protect this groundwater resource. The place where we live, from a groundwater perspective, it's pretty easy to understand what's going on over here, which is fortunate for those of us who study groundwater. Think of the aquifers that are below us as pancakes. Here on Long Island, we have one layer. Here's the surface. We have one layer anywhere from 30 feet to maybe 200 feet below us. That's called the unconfined aquifer. There's just sand and gravel between the water table and the surface. Then below that is another aquifer, and it's separated from this aquifer by a relatively impermeable layer. That layer can be several hundred feet thick. That aquifer is what we call the magathy. Below that is still a third aquifer, maybe 1,000 feet down. That's called the Lloyd. Now, before there was so much activity here from people, the residents had their own wells, and a lot of people still have their own wells, and these wells tap the first aquifer, the unconfined aquifer. Then, as development continued, the public water authorities came in, and they recognized that the water that was available in this unconfined aquifer was becoming affected by people's activities. So they put their wells in the magathy. Now some of these wells are being affected. And the next question is, well, what should we do? Where should we put our next wells? It turns out in Nassau County, some wells actually go down to the Lloyd. To the best of my knowledge, there's no drinking water well in Suffolk County that's being used right now that taps the Lloyd. Okay, so that's the situation, but here, these are great little arrows over here. Let's see if I can use that. The water that we drink coming from the ground actually comes from the atmosphere, obviously. So that we could protect our groundwater sources if we could somehow control what happens to this precipitation, this rainfall, from the time it falls till the time it arrives at the aquifer. And that's what I want to talk about tonight. So let's look at this. And we will ask ourselves basically two questions. The first question here is, what can we do to keep our groundwaters pure, not only for us but for our children, and plentiful, so that our children will have enough? Clearly, the guiding principle here has got to be prevention, because if you and I will actually tell you that a couple of years ago I had a student who took issue with this. By the way, please feel free to stop and ask questions. And if I get too close to the end, somebody goes, so I'll know if I'm going to fall over. I'm a little worried about that. One of these students actually took issue with what I'm about to say here, because his attitude was, why should we spend all of our time and effort preventing? Let sprawl happen, let contamination happen, pump the water, and if it needs to be cleaned, clean it. Well, that's a bit simplistic. He maintained he could make a good economic argument for that, but ultimately what it really amounts to is, I turned to him and I said, would you drink water that you knew was contaminated, but that was treated? And he said, oh, sure, we do it all the time. I said, well, how about if it was contaminated with pesticide like aldicarb? No. That class of stuff I wouldn't drink. So I said, well, that's the problem, you see, because we're not talking here about substances that engineers at the turn of the century were talking about. We're not talking about nitrates, phosphates. We're talking about organics, materials that could be considered toxic to us and hazardous to us. Big difference here. Well, what I'd like to do here is to outline a procedure here where we identify the land. Remember, we're trying to protect. So we have to identify the land which in some way is attached to the sensitivity of the groundwater resource. That's the first thing we have to do. And then, knowing that, we have to say, how can we develop some kind of comprehensive plan to manage this potential resource? And ultimately, the idea here is to, when you identify these lands, is to either restrict uses that are there already, or to focus on publicly held land, where you can do something already, or to encourage activities in these critical areas which lend themselves to clean groundwater. Discourage those things which could affect the groundwater in a negative way. And the next question then is, knowing all that, how do you know which land to protect? We have lots of land out here. Is it all equally important from the perspective of clean groundwater? That's part of this. And I will outline a 6-step procedure here that you see in front of you. So the first thing will be, and I'll go through this step by step, and again, feel free to stop me. First thing is we want to understand in a general way how the contaminants will get into the aquifer. And then what are the important things to be considered here in this problem? And then what can we do to identify the potential of a land unit to either help the contamination problem or hinder it. Then I'll talk about, knowing all that, what type of information to gather, how to go about it, where is it, that sort of thing. And then we'll talk about criteria that we could develop to implement some of the procedures we're talking about. And this is where the reality comes in. And then we'll talk about, and then of course if you know all this and you have enough resources, you buy the land that's critical and you're on your way. So let's talk about the first step here. And let's see if we can understand how contaminants will get into our groundwater. Okay? First of all, I'll try to give the people credit who are saying that people don't deliberately contaminate groundwater. You maybe have been reading the newspapers the last few days, for example, in Russia. There were stories that in the nuclear waste that they're finding, that Russia, there was a deliberate contamination of surface and groundwater. People knew what they were doing, that they had low and high level radioactive waste, they had to get rid of it, and they simply pumped it into deep wells. That actually did happen. We know that. We thought we knew it, and it's been confirmed. Here, let's say to ourselves, well, let's suppose that people aren't doing this intentionally. So there's no deep well injection going on here. Still, how does stuff get into the groundwater? Well, if you remember many years ago, about 15 years ago, there was a problem here with aldicarb out on the East End. In Suffolk County, the major crop has always been potatoes. Now we're seeing a change to grapes, which is it's kind of interesting. But farmers have a lot of money invested in their equipment. Farmers don't want to have to buy expensive equipment for crop A and crop B and crop C. It's more economical to say, I'll make an investment in one type of equipment. Well, this is what happened out here. And of course, we're always taught, those of us who grow tomatoes and things on a little patch of land, don't plant the same thing year after year. Well, the farmers were planting potatoes year after year after year. And what happened? There was the potato nematode came in and started to wipe out the crop of potatoes. There was a chemical on the market. It's called aldicarb. Its generic name was aldicarb. It was manufactured by Union Carbide under the name Temic. There's one example I'm using of the many things that ended up in the groundwater from different activities. So I'm not picking on Union Carbide. This was a chemical that Union Carbide claimed to have done due diligence on. And it proved to the government that it would photodegrade after it was applied to crops. Well, it was licensed. They went ahead, they produced it, they sold it to farmers, and the farmers, it was claimed, didn't apply it properly. They overused it. This is what Carbide said. Well, it turned out that the Temix showed up in drinking water wells. And these were wells, mind you, this is out east. So we're not talking about public water supplies here. We're talking about those wells that were tapping the unconfined aquifer. And Temix was showing up, down gradient. And that's by that I mean the groundwater is flowing this way, and you apply it here, and in a direction away from the point of application in which the water is flowing, it was showing up. Well, it turned out that Temix wasn't photodegrading at the rate at which Carbide thought it was. And Carbide found this out first. They did some experiments, and they did something very unique in United States history. They went to the EPA, I believe it was, and said, take our license away. We don't want to produce this anymore. Of course, some skeptics think they did that so that they could avoid liability. And it didn't work. What happened was that they were sued. And there were a lot of different problems, legal problems. They came out here and they said, we will give any household that has been affected by our product, down gradient from a farm on which it was applied, we will give that family a free water treatment system. Now, of course, the filters had to be changed every 6 to 8 months, and that was an issue. Who was going to pay for it? Who was going to do it, etc. The bottom line was, that's the way in which our groundwater is being affected. You apply something to the surface. It could be on a plant. The plant takes it up. It's a systemic. It goes into the body of the plant, through the leaves, ends up in the roots. The plant could be plowed under at the end of the season. That stuff is in the ground. It could be washed off shortly after it's applied by rainfall. Gets into the ground, percolates down through what's known as the unsaturated zone, also known as the vadose zone, and hits the groundwater. Now, that unconfined layer is not completely isolated from the magathy. There are places where the water in the unconfined aquifer recharges the magathy. And that is where the contamination gets into the magathy. So the question is, if we could understand this process, we could find those lands where this recharge is taking place. And that, of course, would be the location in which we want to save, shall we say, the aquifer somehow. So what's going on here is what's known as an advective dispersive contamination. That's what's going on. And sometimes there's decay. Some of this material doesn't decay. So how many of you have seen what we call tank and yanks? You drive by a gas station, and it's your favorite gas station, and it's shut. What are they doing? They're excavating, they're taking the tank out, they're putting a new tank in. Why? Because the gas tank was leaking. Most gas tanks, it turns out, at gas stations are leakers, and they've got to be yanked. There's a big business around the country. We now have what's known as the underground storage tank problem. It used to be called LUST, Leaky Underground Storage Tank Program. But the government realized that they had to do something, so they chopped the L off, and it's called the USD program. So that's another way in which our aquifer can be contaminated. And in fact, there are a host of ways in which, and I hope you can see this, I'd rather not touch this to zoom in. Can you see these? There are a host of ways. So there are 8 different ways I've listed here in which aquifers can be contaminated from activities on the surface. If you're above the water table, this is the point at which you hit water when you're drilling. You go down, and then suddenly at some point you hit water in your well, and that's where the water table is. You could be introducing contaminants above the water table. You could be introducing contaminants below the water table. And there are a host of different ways in which contaminants can be introduced into our groundwater. Most of the developments that we all live in, somewhere in our developments there are sumps. There's like an area that's fenced off with a cyclone fence. There's a hole that's been excavated, and we were told that was to protect our groundwater. Well, it's to make sure that the rainwater goes into it and recharges the aquifer. But what happens? This rainfall, before it gets there, is going through our streets. And what's in our street? Cars. Most of our cars are leaking oil at some point, and oil gets washed in. So these sumps, believe it or not, can be sources of contamination. And you go to a mall, you look down, you see oil. When it rains, that oil is washed off the asphalt. Where does it end up? It goes into the ground. So we're contaminating our groundwaters almost by anything we do. So what are some of the things that we should be concerned about in this quest of ours to try to come up with a set of rational things? I call them generic data elements, things that affect the quality of the groundwater. And these are the things, if we knew what they were, we might be able to do something with. For those of you who are in 595, some of these things are called state variables. They're describing our system, right? Well, what are they? Certainly topography is important. If you have an area with steep slopes, the water will wash off. If you have a flat area, that's where the water is going to pool. So you want to be concerned about areas that are flat. Well, Long Island is flat, basically. You want to go to areas where you don't have to go too far to hit water. The longer the path of a contaminant from the surface till the time it hits the water, the more likelihood it could degrade. So the areas that have shallow water tables are important. The areas that have a lot of vegetation, they can take up the water and transpire it. So we have to be concerned about those, but we also have to be concerned about areas where the soil is friable enough so that the water can go right down. Those are some of the properties in our recharge areas. So we have this and this. Aquifer thickness. If we have a shallow aquifer, but it's very thin, there may not be a lot of water there. So we have to be concerned about places where the aquifer is thick. We have to be concerned about the chemicals we put in. We have to be concerned about the things that they interact with. We have to be concerned, ultimately, with how long is it going to take a pollutant to hit the water. That's what we have to be concerned with here. And then there are a host of other things, which I won't go into. But these are some of the important generic elements here. And what I'd like to do now is to say, okay, if we know now what's going on from a physics point of view and from a chemistry point of view, and we know the kinds of information we might be looking for, what can we do with it? So I'm going to give you 3 examples of 3 things that are available to us. Literally, these things are available to us today. The first example has to do with something that's really big now in the environmental field. It's called GIS, Geographic Information Systems. And for those of you who are looking for employment in the environmental area, this is an area you might want to think about. Those of you who are computer literate, for example. The idea here is this. You collect diverse data of the sort we were just talking about. Land slope, density of population, where your roads are, that sort of thing. It's all very diverse. But there's a commonality. And that commonality is if you attach to each datum a location, let's say a latitude and longitude. And then you put this data into a computer so that each of these data types forms what's known as a layer. So for example, suppose you were interested in the plotting where all of the paved surfaces are on Long Island. So what would you need? You'd need to know the location of all the roads, and you'd need to know the location of, let's say, shopping centers, and probably airports. So that would be one layer of information. And then what you do is you put these layers together. Let me give you an example here. So each of these data types forms a layer. This technique of layering was actually invented by a land use planner at the University of Pennsylvania, I think 30 or 40 years ago. His name was Ian McHarg. And he had his graduate students putting this information together on Mylar sheets. And he would color these sheets. And then he would overlay them on a light table. We don't have to do that anymore. We've got computers that can do this. You can go out and for a couple of $100 buy software. Actually, it's more like a couple of $1,000. And you buy software that'll run on probably a large PC or a mini computer. And you put this data in, and then you have the computer overlay all of this kind of information. And you get this building up one after the other. And what you have here now is a system where, go back to this over here, let me go back. You have now a system where you can do what's known as spatial statistics. You can say to yourself, show me those places, and you can actually ask the computer this using Boolean algebra. Say, show me those places where the topography is shallow, where the recharge is greatest, and where there's a lot of open space. And it'll come up on the screen. The computer does this automatically. You can actually use numerical transport models. We'll talk about that in a minute, on a GIS. It's a very, very, very powerful technique. For example, the Suffolk County Department of Public Works is actually, as we speak, putting in information like where are our sewer lines, where are our electrical lines, where are all of our utilities. The idea here is get to a point where if a contractor wants to open up a piece of property and do some building, they will know where all of these underground lines are. If all the roads are being put in this, because the emergency medical services, when they take off and they know there's an emergency somewhere, as they're driving, somebody can get on the radio and tell them which are the best roads to take. They'll know the traffic, patterns on there, they'll know the roads. So it's a very, very powerful technique. So if we could put our data together such that we could use GIS, that would be a good tool that we could use. Now there's another tool. And I'll give you an example of one of them, but there are many. There's a technique that was developed by the National Water Well Association several years ago, and it goes by the name of DRASTIC. DRASTIC, it's an acronym, and it has 7 data elements that, using an expert system, and I'll tell you about that, they were able to come up with 7 of these generic attributes that could be used to help identify where critical lands are to protect the groundwater. And what they simply did was they brought a whole room like we have here today. Each one of you has a certain type of expertise. There could be geohydrologists, there could be people who are into demography, there could be engineers, there could be scientists who are really hot and heavy on groundwater transport, there could be public officials, and all these people are brought together in a room. And then you're asked a series of questions. This is called the Delphi technique. Some of you may know about this. It was developed by the Rand Corporation around the time of World War II. And the idea is this. You ask the group, tell me what the 10 most important parameters are to address this particular problem. And each one of you will give me a sheet of paper. And then I'll run in the back room, and I'll have a bunch of students in there who are putting all of this together, and then 5 minutes later I come back and I say, here's the list, folks, and each one of you gets the list, and you get your answers to me. So, and then I say to you, this is what you said. This is the list of what all of you said. You want to change your answer? I'll give you a chance. And then people change their answer. And then I ask you another question. I say, tell me which are more important than the others. So you give me information, and I feed back information to you, and we iterate. And ultimately, what comes out of this expert system here is an index. It's a way of saying, which are the important things? How do I rate them? How do I put numbers to them? And then how do I put them together such that I have a number, an index? And so what they defined here were 7 parameters: depth to groundwater, recharge, what the aquifer media is. Zoom in there a little bit. Right there. What's the soil type? What's the topography like? How important is the vadose zone? And what is the hydraulic conductivity of the aquifer? And what they did was come up with a bunch of tables. Let's focus in on this table over here. So the people said that if you could give 5 as a numerical number to the thing that's most important, and 1 to the thing that's least important, these would be the weights. So each one of these parameters has a weight, and then, let me move to this one over here, for every one of the individual parameters, you would define some kind of function that would allow you to say it goes from a scale of, let's say, 1 to 100, or 1 to 10, or whatever. So you get a curve like this. So not only does every parameter have a weight, but every parameter also has a value. And then you put all this stuff together. And then you color the regions. And this is what you get over here. It's called a map of the groundwater pollution potential. This is an actual map of Newcastle County, Delaware, where this was done. And every square, let's say square mile, or every acre, someone put the data together for these 7 parameters and then came up with an index, and they plotted it. So it turns out that this color over here, this blue area over here, has a number from 100 to 119. And presumably what it means is that these blue areas are very, very important relative to the other areas in terms of groundwater contamination. This just looks like a GIS, doesn't it? It's an overlaying process. So the index concept and the GIS concept are very, very similar. And they are ways in which you could actually go out, collect data on land, put it together, and then try to evaluate which piece of property is more or less important from the perspective of groundwater. Now, for those of you who are into the heavy-duty mathematics, there is transport and fate modeling, where you get a differential equation where C is the value of a concentration, let's say temic, and you want to know what the concentration of that substance is at any time, at any space. And you can put together what's known as, for example, a leaching potential index here. So if you look at this equation over here, and you say that under steady state conditions, steady state is when the derivative of that substance with respect to time is 0, and where dispersion can be ignored. Those of you taking 595, I see you're smiling. We've covered this there. This term goes to 0. This term will go to 0. This term will go to 0. And you're just left with these 2 terms down here. And that's our you thought you'd get away from me by not hearing this, but what type of equation is that? It's a linear, first order differential equation. It's the one that you thought you'd never hear again. I told you I was going to come after you on this one. So this equation can be used to come up with an index. Okay? So here are three ways of doing it. There are many other ways, I'm sure. But what we see here is this. We've identified parameters that somehow connect what's going on at the surface with what goes down to the groundwater. So whatever they are. We can put that information into a computer using a GIS. We can put this information together mathematically in the form of an index. We can use a differential equation. But we can do it. There are many ways in which we can take attributes of land and convert them into numbers that relate to how important that land is to us from the point of view of groundwater contamination. And so now what we're left with doing here is gathering this information. And there are loads of sources to get this information. They're all over. They're here at the university. Professors have this information. Building 40, that's the New York State DEC, regional office. They've got data. Government agencies have data. Private water companies have data. There's no lack of information. In fact, somebody at the National Water Well Association put something like this together, and they found that the information you need is out there. That's the bottom line. The information is out there. You just have to get it. So if you could get it, you got all that information, and then you use it, you could develop the criteria you need to define which land is most important. And now, if you're a land use planner, you can now say, I can start making decisions on what land is most important, and then what do I need to do for that land to protect the groundwater. What I'm saying here is, what's the easiest thing to do? Buy it. If you've got it already, protect it. If you don't have it, buy it. Now comes the problem. Because first of all, money is tight. You can't buy all this land. And two, if you take it, people are going to complain. So now, those of us here who are engineers have a tough problem, because now we step out of the realm of rationality. This is all rational, what I've been telling you now. Let's now look at reality. And you'll find that when you go from the academic environment to the real world, problems exist. And hopefully I'll give you a perspective on what actually happened out here on Long Island. And by the way, for those of you who may have read Newsday today, the situation is still unfolding. It's not finished. There's a big controversy now because the Pine Barrens Association is going to honor our Suffolk County executive, and there are a lot of environmentalists who say don't do that. The guy's not a protector of the environment, and there's a big battle developing. So the story's not over. But in any event, let me give you some flavor as to what happens. Those of us now who are in the room, going through what I've just gone through, we may say, well, all right, we know what to do. We can go out there, and we can identify the land that's most strategic, and then we can develop a plan and make some decisions as to how to implement the plan and do it. That's what I call science over here. And that's rational. But the real world here says there are other considerations. There's a finite amount of money. There are a lot of people whose they have a lot of oxen, and their oxen are going to be gored. They don't want their oxen to be gored. There's a real estate market out there. There are people who have plans. They're going to put up shopping centers, and they're going to put up homes, and there are a lot of people who need homes, and they have plans too. They're going to get jobs. They're going to move out here. They want a nice place to live. They're going to bring their cars with them. They're business people who are going to grow up around these people. And this is all reality. And this is all going to affect our problem here, which is the groundwater. Well, who are some of the actors involved here? You have a lot of different levels of government. Some say we have too many, but there are a lot. You have the federal, I didn't even list them, I think, here. You have the EPA, the U.S. EPA, and their regional office is in New York City. Then you have the New York State Department of Environmental Conservation. They're in Building 40 on campus here. And then you have the Suffolk County Legislature. And then, of course, you have the Suffolk County Executive, and sometimes the executive and legislature don't get together. Then you have park trustees, and you have the health services. We have a very large group, very important group, called the Suffolk County Water Authority. Suffolk County Water Authority provides all the public drinking water in Suffolk County. If you live in Stony Brook, you pay a bill to the Stony Brook Water District. But they get their water from the Suffolk County Water Authority. So it's the Suffolk County Water Authority, irrespective of who you're paying, that's giving the water. They're developing the water, and they're providing it. Then you've got the towns. And for Suffolk County, there are 3 towns we're going to be interested in tonight: Brookhaven, Riverhead, and Southampton. You'll see why in a minute. Then you've got environmental groups like the Nature Conservancy or the Environmental Defense Fund. Lots of them out there, lots of them. And then you've got planners. And you've got academicians. And then you've got the business community. And then you've got people like us. We just want good drinking water, right? So there are a lot of actors here. And what I'm going to do here is give you an example of a couple of the actors, where they're coming from, what they did, and how they affected the problem. So one actor was New York State. And New York State, I'll give you a timeline on this in a minute, but New York State tried to develop a groundwater management plan. And there were these regions that were developed. They were called special groundwater protection areas. And there was a whole plan. This is the cover. Let me see if this will come out. But this document exists, and it caused a great deal of interest. Unfortunately, very little came of this. So this was a good attempt, a valiant attempt. It involved citizen advisory councils, but there were problems here. First of all, the legislature here in New York State, they said they would put money up, but they didn't give any more direction. And they got involved. There were problems here. How do you draw these lines that define these areas? People were saying, you're gerrymandering. What you're doing is, some of you represent rich people who own a lot of land. And they're going to develop this land. And you put their property outside the district. So, they're going to develop their land. Their land is in a critical region. It should be inside the district. And then they're saying, no, it should be outside. So it was a big set of problems. Very little came of this. But it was one of those nails in the coffin, so to speak, that got a lot of people thinking, you know something? We ought to do something about this problem here. Then there's the Suffolk County Water Authority. Remember I told you, they're the ones who purvey the water. Very, very important group. They got a lot of people together, and they began with something like drastic. So here's the drastic system. They came up with an index, and they got a lot of the actors together in the same room. They got government people together with private people. They got builders into the group. They got all sorts of environmental groups together. How they did all this, some of these meetings were incredible. I can tell you, I was sitting there, and the only thing that kept us together and friendly and amicable was the fact that it was usually done around dinner time, and the Suffolk County Water Authority provided the food. So when things got hot and heavy, there was always a chance to say, let's take a break and have dinner. And that usually cooled things down. And believe me, there were lots of arguments. Lots of arguments. People were jumping out of their seats, and sometimes things were thrown around. It was amazing. Anyway, they came out with an index. And there was an honest-to-God good attempt here made to try to look at clumps of acreage on Long Island and to come up with a plan, something like this, to identify those areas which are most important. They were trying to make the decision there. What areas do we have to do something with? Where should we acquire this land? Well, they came up with something that looked like this. This is the map of Long Island, and they actually would try to define areas which were critical. These are the areas where, if you had the money, you should buy, if you're in the public domain. If you're in the public domain and you could pass a law restricting development, these are the areas. It was a good attempt, but as you see here, it was abandoned because it gave, it was a facade of objectivity. But ultimately, in forming these indices, because of all of the controversy involved here, there was a lot of subjective judgment brought in. And of course, when you go from the rational and you start bringing in things that are, shall we say, irrational, you have problems. People, suddenly, your credibility is lost. This is a big problem for decision making, as you know. We try to be rational, but at some point, you do something which is not totally rational, and then the credibility goes, and then you have a lot of problems. Well, let me just give you a quick timeline over here, because we have been grappling with this problem on Long Island for a very, very, very long time. I start this from 1974, but actually it goes earlier. In 1974, Suffolk County had a farmland program, and their idea was, let's look at the farms. Let's try to, if we could, buy some of the farms, let the people farm, but buy the land, the development rights. Let's do something. Then in 1978, there was a comprehensive waste treatment management plan. There is what's known as the Long Island Regional Planning Board. It's in the Dennison building along, what is it, Route 347. And it's comprised of planners from Nassau and Suffolk County, and they put together this plan together with a lot of input from all sorts of people, and they came up with this plan. And actually what they defined was a concept known as a hydrologic zone. And these were these, on the top there, are these things that are called deep flow recharge areas. They published 2 volumes of this. And they actually showed, here's Smithtown, right there, here's the town of Brookhaven, and they showed where these areas were. And these were tied together with geohydrology. Very rational, very, very rational. Only one problem. It's okay to draw a picture like this, but if this is going to become law, you have to publish in a newspaper the borders. You know, you go down Nichols Road until you hit 347, then you go 10 miles east along 347, you go north along Route 112. Now, at that point, you're starting to gore someone's ox. It's okay to do this, but when you do that, now you got a problem. And that's exactly what happened. Well, the history continues to the present. And in 1987, something very important happened. Those who had to make decisions came up with this idea, why don't we raise the sales tax and let's take 1/4% of the sales tax and put it into a fund where we could target land that we want to buy. So they did that. They thought they would generate $60 million and they would get about 5,000 acres. What's the problem? As soon as people learned about this, what happened to the cost of an acre of land? So land that could have been purchased for $100 is now a couple of $1,000s an acre. And your $60 million doesn't go all that far. Well, we had to do something, and lots of groups got together and they formed the Long Island Pine Barrens Society, and they sued. And there was a long spate of legal action, and ultimately it came down to this. is it necessary to put together a comprehensive plan, an impact study for anything the government wanted to do? And there was this plan that had been put together. Well, this went to the state Supreme Court, and the court said, no, it's not necessary. It's a good idea, but it's not necessary. And that sort of broke the back of a lot of the litigants. And at that point, people said, instead of fighting, why don't we sit down and do something here? Because the builders knew they were getting a bad rap, right? Open up a newspaper, and what does it say there? Builders want to build. They're bad guys. Well, the builders, they do want to build, but they're not all bad guys. And we're paying a lot in taxes. Well, how do we support ourselves out here? We need a tax base. We can't just have open space. We have to have people living here, paying taxes, making money, industry here, paying taxes. So we need to do something about our economics. Well, what happened? In 1993, this was, no pun intended, this was a watershed year for groundwater protection, 1993. In 1993, there was a very important conference here, right here at the university. It was called the Long Island Water Summit. It was held in, I think it was in Staller Center. And it was very well attended, hundreds of people. And they came here, and the idea was, let's present the information, everything we know. There were geohydrologists, people from Earth and Space Sciences Department came here. The government people presented the information. The builders presented their case. The environmentalists presented their case. And a lot of newspaper coverage. The media was there, Channel 12, etc. And that was followed by a conference held in Melville, which was called Why Can't Long Island? That was more the business community. And those two conferences brought a great deal of awareness that something had to be done. Well, in 1993, the New York State Legislature passed the Long Island Pine Barrens Protection Act, which created a process which ultimately is leading to the third largest New York forest preserve right here on Long Island, the Pine Barrens area. So we can talk about this. Let me just tell you what it does. It's a very, very important situation. It's where we are now. The comprehensive plan, these are decision makers. They knew that they could identify where the critical areas were for protecting the groundwater. And they knew that some of that land was more important than others. So after a long drawn-out process, two areas were defined. One was called the Core Preservation Area, and this is the most important land using the generic elements I showed you before. This is called the Central Core Preservation Area. These lands absolutely must be protected from any activity that could affect the groundwater. And then, surrounded by that, is another area. Now, there are 52,500 acres in that Central Core area. There are 47,500 acres in the compatible growth area. This is an area that rings the Pine Barrens, that it would be nice if it wasn't developed. But recognizing that they will be developed, the question is, what can we allow to go on there? We can allow things to go on there. And then some people, and I don't quite remember who, came up with a very good idea. They came up with this idea of transfer development rights. Great idea. They would create what are known as Pine Barren credits. It's a certificate. So if you owned land in the Central Core area, if you wanted to, you could get a certificate that said you got N number of Pine Barren credits, which they created what's known as a Pine Barren Credit Bank, literally. And you could present this certificate to the bank. And what you could do is you could sell that credit to the bank and buy the right to develop land to an equivalent amount of credit in the surrounding area, the compatible growth area. So you, if you were owning land that was very valuable, but in a critical area, you could still make money. So the economic part was still there. But it wouldn't be where you own the land. It would be somewhere else. And that land could be then taken out of the private sector, put into the public domain, and protected. And that's what's happening. Now, this land acquisition program is now combined with this other program called Transfer of Development Rights. And then, on top of that, is a comprehensive land management plan. And this is where we are now. As I told you before, there are still problems because Brookhaven, town of Southampton, town of Riverhead, they're the towns in which the central core properties are located, and they have to approve this. But I'm sure they will. I'm sure they will. So, of course, this is the real bottom line here. From the perspective of what we're talking about here tonight, the bottom line is, have we done anything to protect the groundwater? Now, that question is still out. We don't know if we have. But the important thing here is what I've described to you is a process that you face if you're a scientist or engineer or someone doing work in a planning area where you're trying to come up with a rationale based on principles, scientific, mathematical principles, logic. And it seems very understandable. Why doesn't everybody do this? Why don't they believe me? But they don't believe you. And this is something we've gotten a flavor of in ESD 595, which is Principles of Environmental Systems Analysis. There's a conflict. We think we come up with sound principles for decision making. But what we forget, or, well, we don't forget it, we don't have to face it because here we are on a college campus and we're not faced with the realities of the real world. So we can develop these theoretical stratagems. But when you go out there and you want to apply this, you're always faced with, shall we say, extraterrestrial type of considerations. People own land and you're going to take it. People pay taxes and you're not going to give them value added. Politicians want to get reelected and they're going to say things that don't make sense. Environmental groups who will distrust you even if you're trying to do something to protect the environment because something you're saying will lead to something that they're fighting. Environmental groups that are fighting one another and you're getting caught in the crossfire. What do you do? And this is what I hope to give you here tonight is some insight into how you can somehow effectuate what you're trying to do. What I call it, some people call this co-opting the enemy. I don't look at it that way. You have to include, you have to identify all the actors. And then you have to include them in the decision-making process. It's very important because you want their buy-in. But to get their buy-in so that the right decisions can be made, and I use that word right loosely. I mean, we think we know what the right solutions are because we're the ones who came up with a rational approach. We need their buy-in. And to get their buy-in, we have to give something up too. And maybe we don't want to do that because our logical construct is telling us that's wrong. But if you're an engineer and you want to get something done, you've got to identify all those people who own the oxen. And you have to identify what they want. And you have to get them together and you've got to get them talking and you've got to teach. You've got to teach them the physics and the chemistry and all the other principles involved at the level at which they can understand it. And then you've got to sit back and listen to them and hear their considerations, things that they consider important. And then you've got to put all that together into some kind of framework where you can make a decision and get something done. And in the case, as I say, of groundwater on Long Island, this is it. Everything, all of the work that we've done for the last 20, 30, 40 years has been boiled down into this document. It's a The first part is the policies, programs, and standards. Then there's existing conditions, and then there's an EIS, an environmental impact statement, and this is all for the Central Pine Barrens Plan. If this thing is approved, then I believe this is our last chance to save our groundwater. But this came about through a lot of careful and not so careful work by a lot of people who fought sometimes, went to court sometimes, but ultimately got together and made the right, I think, the right decisions. So I hope I gave you some insight into how these things have gone on out here in our own backyard. I believe from my own professional experience, I've seen this kind of thing go on before with the nuclear power plant issues, for example, and with other areas, geothermal energy development, that sort of thing. It goes on a lot in a lot of different areas. So that's the story, and I hope you go out there and help us make some good decisions in the future. And if there are any questions, fire them at me.
The issue of transfer of development rights, where you're shifting the development capability from one location to the outskirts, where I presume the groundwater is not such a sensitive issue. Are there actually exchanges of property?
Through the vehicle of the credit. So there's a set of formulae, how much land you have, how many houses could be developed on it, how many people would be there on that land if it were developed, and then that boils down to the number of credits you'd get. And that would be a valuation that you could then separate from the land, sell it to the bank, and they would in turn locate land of suitable credit somewhere else where you could develop and make your money.
They decided what suitable was, or?
That's in there. That's in there. Each one of the three towns, Brookhaven, Southampton, and Riverhead, are doing it on their own.
Some years ago, there was a large brown water leakage from the tanks from the Northville Oil Company here in Setauket. A number of years have gone past. Do you know the direction of the plume, underwater plume, and where it is right now?
Well, it's kind of interesting.
Could you repeat that question?
Yeah, the question is, several years ago, there was a major oil spill right near this university. What happened? I guess, where did the contaminant go? For those of you who drive down Lower Sheep Pasture Road, just about where it gets to Old Town Road, in that area. If you go from that, if you were to drive from there south towards 347, there's a large tract of land where Northville Industries has storage tanks. Northville Industries is probably the largest, maybe the only, company that imports oil and also gas onto Long Island. And they have a large storage tank farm there. By the way, when they put that storage tank farm up there, we were not here. This university wasn't here. It was pristine. And then sprawl caught up with it, and homes were built right around it. Well, it turns out that Northville Industries discovered the fact that its tanks were leaking. Slowly, over a large number of years, about 1 million gallons of gasoline had leaked. Now, you could say, how did they not see it? 1 million gallons of gas, that's a lot of money. Well, I don't know. But they found it, and the plume was moving north from that property. And there are a lot of homes. It's called Storybook Village over there. And the plumes were moving underneath some of the homes. And as soon as the word got out, of course, if this was your house, that's how much it was worth. So Northville Industries came out, and they took the rap right from the start. This doesn't happen too often. And they said, we'll buy your house. If you can show, if you could show that this was a problem, and if you would find, there were lots of wells drilled in the entire area. It was pockmarked with wells looking for the plume. And it turned out that the plume dogleg, see, those of us who thought we knew geohydrology didn't realize that there were various layers, interleaving layers of clay and so forth down there that we hadn't known. And so what happened was we thought this was Long Island and it was homogeneous sand and gravel and the plume would move this way. And actually what happened was it went this way and up, like that. Well, that's for the plume. Let me just tell you what happened because it reflects on a Pine Barren thing. There was a settlement. And some of that money is being taken out of the fund and loaned to this program so they can buy land out east. And then when it gets paid back, that money will buy some of the land in this, it's known as the South Setauket Woods, because that also is a Pine Barrens, but it's not included in this bill. And if those of you, if you've seen that there's a development park, industrial development park down there, and that is very important land. That land, from a groundwater perspective, needs to be preserved. So some of the money from the Northville settlement will be used for that.
And which is the direction of the plume now, do you know?
I don't know exactly, but you could find out by just going to Building 40 and asking to see what the latest maps look like. Yes?
Could you tell me, in your opinion, how safe Long Island drinking water is?
Question is, in my opinion, how safe is the drinking water here
The
on the
reason for
island?
that is once I boiled water and it was there for a while, I saw a yellowish stain in the water. And I hear a contrasting opinion from the people that government tells you different things than what they actually do.
Was this water from your own
Tap
private
water.
well?
No, so regular tap water.
Regular tap water.
Apartment building.
Apartment building?
Yeah.
Okay. The water, to the best of my knowledge, the water that the Suffolk County Water Authority is providing is just about the best quality water you could possibly get. In fact, almost tongue-in-cheek, the head of the Suffolk County Water Authority proposed that we bottle that water and sell it upstate. Now, when you buy water, bottled water, do you know where it's coming from? And do you know that some of the plastic leaches from the bottle? I mean, if you have a choice, would you buy a glass bottle or a plastic bottle? I'd buy glass. Because it was found that some of the plastic material ends up in the water if it's on the shelf life. Number one, you don't know where it's coming from. Number two, you don't know what they're doing to it. And number three, there's a problem with the packaging. I don't understand why, I mean, in my opinion, I don't understand why people are buying water out here on Long Island if they're getting Suffolk County Water Authority water. It's good water, very good water.
What's the situation out of Brookhaven National Lab with the water that's being pumped into the Peconic River? Could you give us some insight into that?
The Brookhaven National Laboratory, the question was, what's the story with Brookhaven National Lab and the Peconic River? Brookhaven National Laboratory happens to be located in this central Pine Barrens area. And the water, the beginning of the Peconic River is on our site, actually. And sometimes our sewage, treated sewage, is the Peconic River, because it's so dry at certain times of the year that the water's not coming from elsewhere. And every year, Brookhaven National Lab publishes an environmental quality report, very detailed, and all of the information you want is in it. My understanding is, and I'm not in that group, but from my understanding is that yes, there's no question, but that Brookhaven National Laboratory has affected the Peconic water. There are chemicals that may get through. In the past, there's some low-level radiation that has gotten out. And at this moment, there's a multi-million-dollar cleanup of various activities at the lab. It's a Superfund site. And that information is publicly available. Very easy to get.
Didn't they just get a permit to pump all kind of new water out into the river?
I don't know. I don't think we're pumping water into the river. I haven't heard of that one. There are pump and treat operations out there, which is a pump and treat is a way of, if you know where the plume is, you put a well in there and you try to suck the water out that's contaminated and then treat it at the surface, perhaps, and then re-inject it back in the ground, up gradient, so that you dilute it and clean it up.
Like a lot of those gas stations have now, that type of situation?
The gas stations mostly have air strippers. You'll see, they try to hide these things through, they build like a fence around it and they paint it green or something so that, you know, it blends in. But if you know there's a gas station that's suddenly put in new tanks and then you see a structure behind it, usually it's like a tank, what they're doing is they're pumping out groundwater, and it's like a trickling filter. They pump it at the top and the water goes down, and inside this cylinder are pieces of plastic in various shapes. So what it's doing is as the water comes down, it cascades, and they blow air through in the opposite direction, and the air strips out the volatile substances that are in the groundwater. And then they can re-inject the groundwater back in the ground because it's been stripped of the gaseous material, the gasoline products. Any other? Yes?
There are probably some businesses within this area that's going to be protected, that possibly like the sand pits that you see when you're flying into MacArthur. How are they going to be treated, and are they going to be
That's a very
removed?
good question.
Can you repeat that?
There are open spaces that are commercial activities, I guess, like sand pits, quarries, that sort of thing. How will they be treated under this plan? I don't know the answer to that because I don't know how many of those are in the central Pine Barrens area.
How would a sand pit affect groundwater?
Well, in some of these cases, as you mine the sand, you eventually intersect the water table. And you're sort of, basically what you're doing is just think of it as a living thing where you're making an incision and opening up the body, and you look inside and there it is. So you're stripping away some of the natural protection. Think of how much, here on Long Island, how much topsoil we have. You know what the average amount of topsoil is on Long Island? It's about 1/2 inch. And that's where everything is growing. I mean, when you think about it, food comes from 1/2 inch to 1 inch of topsoil. The rest is sand and gravel. If you take away, you know, on your own properties, or you look at on our campus here, people walk, they don't use the path, and we don't do it. None of us do it. But when we keep using the same path as a shortcut, it doesn't take more than about a week. And what's there? There's no grass, sand. And where our entire island is so fragile. If we could only protect it, that's the important thing.
Back a number of years ago, I guess under the Long Island Regional Planning Board 208 study,
Right.
a lot of modeling went on with respect to nitrogen recharge from wastewater, and that was linked to certain perceptions of development plans and how Long Island would develop, and of course, things don't always go according to plan. At this time, have there been any other studies, as follow-up studies, to determine whether or not nitrogen is still impacting the groundwater table to the extent it used to?
The question is, have any follow-on studies been made to what's known as the 208 study to confirm, I guess, the impacts of nitrogen? The 208 study was that study from which I took these maps. It was a very, very comprehensive study, and one of the things it identified there was potential groundwater contamination from nitrogen. Where does the nitrogen come from? When we fertilize our lawns, when golf courses are notorious, and they always, no matter how bad the drought, you go to a golf course, it's green. Well, it's green because they over-fertilize. There was phosphorus that was implicated. There were lots of studies done, and these recharge areas were defined, these hydrologic zones. To the best of my knowledge, there were very few follow-up studies done in a comprehensive way. This is the last comprehensive study that was done. as far as nitrogen is concerned. We know for a fact that nitrogen is something that could easily contaminate groundwaters. For those of you who like to use spreadsheets, there's a model called BURBS, B-U-R-B-S. It's a Lotus spreadsheet. It was developed by Cornell Agricultural Extension. You can get it probably for free or a couple of bucks. And you can, that was developed specifically to help towns understand the nitrogen potential, contamination potential, and do something about it. It was made for decision makers.
What about the industry that's already established in the deep recharge areas? Has there been any kind of plan for their staying there? Are they grandfathered in, or?
There are very few major activities going on in the central core. I'm talking about the 52,500 acres are the central core. When this whole thing started, when I got involved in this about 20 years ago, we were talking about pine barrens that stretched from Brooklyn through Nassau and Suffolk. And somehow, in the last few years, it all boiled down to 52,500 acres in the central core area of eastern, this area right here, of eastern Suffolk. There's a lot of pine barrens stretching all the way into Brooklyn that are still open and that are still important. But these areas over here, there's not much in the way of industry over there at this point, thank God.
And the grading index that was it found to be acceptable among most of the major landowners when they had to go from the sensitive land to, did they find it acceptable as far as the scheme that was come up with?
The question was, were these indices found acceptable by the people who own the property? That's a good question, too. We don't know, because this is just starting.
So that hasn't found to be
The program is not fully developed at this point, because over the next few weeks, we're waiting for all of the three towns to pass this. And then once that's done, this is a reality. It's almost a reality, not quite. So we don't know. The answer on that one is out.
I have a question regarding Brookhaven Labs. What is their intentions? You said they were in one of the core areas.
What
Are
is
their intentions to leave it?
What is the intention of Brookhaven National Lab? Brookhaven National Lab is a federal facility that is not going to move. Every one of the national laboratories was made to put together a land use plan if it was abandoned by the federal government. Could happen. And there is a plan that just came out this past summer of all the different things that could be done out there. But we're operating under the assumption that it's not going to be closed and that I'll still be employed. My colleagues will still be employed. And the idea is we are being made to be much more aware of the things we do. So, for example, I'll give you a concrete example. A scientist or technician cannot empty something willy-nilly down the drain. You have to know what you're dealing with, and there are certain things we cannot put into the drain, which goes into our central sewer, and then may or may not be treated. So it's a matter of awareness and cleanup. There's lots of money, millions of dollars, tens of millions of dollars are being spent right now at Brookhaven National Laboratory to clean it up. Well, thank you.
Thank you very much. I'd like to thank Dr. Kaplan again for an excellent presentation. I knew that Ed would do what I thought that he would do, and that he would really give us an indication of this strange mix between science, engineering, politics, sociology, economics, you name it. And so I'm very pleased that he did that. Next time, I'm going to spend time reviewing for the midterm exam, so the entire session will pretty much be devoted towards that review. See you next time.